Good morning, everyone, and may the 4th be with you. We're talking about this gear because you guys have seemed to have a lot of questions about it. So before we get too far into it, I want to go over how to do or how to look at these dimensions. There is a lot up in this region here, um, and I get that. And for a lot of you, we didn't get too far into things, so it was this is probably a shock to the system seeing all this stuff here. You've probably never seen OD like that. That stands for outer diameter. So that would essentially just be this circle here that's going to be on that shape. And then these are tolerances here. So basically, if you're manufacturing that, in order to be pass fail, you have to fit within this range. That's a really small range, but that's how that's how things are made in the real world. This is a thread note. We just covered threads on our drill block. And then this here is a chamfer note. So a chamfer is a tool that we're going to use. Basically, it gives you an edge that looks like this. So instead of a rounded corner like this, a chamfer is this squared off edge. And basically what it's saying to you is there's a 45-degree angle here, and then the line, the angle, yeah, and then the line is 0.3 tall. So it'd be 0.3 this way, 0.03. Man, I cannot write on this thing. Anyway, what we're gonna do with the gear is we're gonna draw half of it. All right, so we're gonna be doing revolution. So we're gonna draw just straight up all the way to the tip of this, and we're not gonna worry about that part first. So all we're gonna have is just this little tube, and then we're gonna revolve it around the center axis here. All right, and then from there, we'll go back in. We're gonna add the gear face, and how we're gonna do that is we'll use some of the information here, like this 0.5 and this 0.25. That'll set our length of the gear itself there. And then what we're going to do is go to our supplemental drawing here, and we are able to see the distances of how wide this thing is, and then how tall off of the shape that it is. Now, it's not an exact science right here. We'll try to get it as close as possible, but this drawing kind of leaves a little bit up to interpretation. What you could do is the outer diameter here is 1.164. So what that tells me is from the center here up to the top of my shape is going to be half of that 1.64. So why don't we start drawing? I have these printed off for myself, so I'm not gonna refer back to this drawing anymore. And hopefully you guys have these drawings either printed or available so you can see it as well. All right, here we go. So this is the Fusion 360 window, and people that are on Onshape, it should work exactly the same, except for the threaded top at the end. But you can still create a hole, you just won't thread it. Start the sketch, nice and simple. And what I'm gonna do, I'm just gonna create a rectangle. And then I'm gonna go back in and start adding my dimensions. Now, I've had one person ask me, how do I do a closed shape or a closed profile, and then 3D fill it in. And it's simple. It's just this shape. There are no open corners on it, and then it will fill for a 3D shape. Let's see. Okay, so I'm going to dimension this line. And then I will find my diameter of the circle at the bottom or on the left side of that shape. And what I'm going to do, I'll just take the number in the middle of those two, so it's 0.749 and 0.748, and I'm just going to do the middle of those two, so I'm going to say 0.7485. And then I will divide that by 2, because remember, we're only going from the center line, so we're only using the radius. And from there, we can actually revolve this thing. So I'm going to cancel out my dimension. I'm going to finish the sketch. I'm going to come over here and revolve this shape, and I'm doing it 360 degrees. Done. All right, so that's set up. I'm good to go there. Now, what I need to do is I need to use an offset plane from the top. So that's going to allow me to draw the gear from the bottom of the gear head. Okay. I'm not using my normal mouse. Okay, so we're going to do an offset plane from this top face, and we're going to go back to the bottom of that gear. So we're going to go minus 0.5, and that'll set me up right there, and I'm going to select OK. Then I want to sketch on that face. Okay, but I want to turn around and go from this side. And so now I'm sketching the shape of the gear. So what I'm going to do is look over at my other drawing here, and then I'm going to firstly draw a center. All right, you know what? Doesn't matter. So I'm drawing that, and then I'm going to draw a line out and down. No, it doesn't. And then instead of doing anything else to that, I'm going to mirror that shape over. So my mirror tool is here. I'm going to select my lines that I want to mirror over, and then select my mirror line next, and OK. And then I'm going to add some dimensions. So let's hide that. My top dimension from this point to that point is supposed to be, wow, 0.074. And then my bottom dimension from that line to that line is supposed to be 0.125. And then if you notice, our height is wrong. So what we're going to do here is what I was talking about at the beginning, where I'm going to go from the center point to the top of this line, and I'm going to use that outside diameter. No. So the outside diameter says 1.164. I'm going to put 1.164 and divide that by 2. And that should give me the height of that shape. Now what it didn't do was stick in the middle. So I'll just go back and add a measurement from, you see how it pulls a few different ways? Pull it straight up and add this measurement in there, just 0. And that should center the line back up, or not. let's do this. So, um, okay, so now I want to add the measurement from the first part of the sketch, which is the outside diameter. This is where I'm going to go from the middle to the top line here. But what I noticed when I did it the first time was that it moved my center line here. And I don't want that to happen. So I'm going to use this constraint. This is fix or lock. So I'm going to lock that center point into place so that cannot move when I add this dimension. Then I'm going to go from the top line to that line, and I'm going to add 1.164 divided by 2, because remember, we're using the radius here. And there we go. That looks a lot better. Okay, so there you finish your sketch. Should rotate me around sideways. It did not. Let's do it ourselves. Okay, so what I'm going to do here is I'm going to extrude this. There you got to select both, apparently. Because that line is splitting it. If you made it a construction line, that would have been it would have been easier, but it doesn't really matter too much. So from there I need to back up. From there we need to back up. We need to go back to sketch 2. I'm sorry, not sketch 2. We need to go back to the offset plane, and we need to change this to 0.75 actually. I missed that 0.25 that was in there because we are extruding this 0.5. This and that, 0.5, and enter. Okay, so there's that. And then what you do with that is circular pattern, which is, that's a rectangular pattern. Go under create, there'll be a pattern and circular pattern. And we're gonna select that feature, not faces, we wanna go features. So I'm gonna select this feature here and select this axis here. And then I'm gonna quantity, there are 12 of them. So add in the number 12 and okay. And there I have the teeth on my gear. So next step is to add the chamfer. So I'm gonna go here to modify. I'm gonna find my chamfer tool. I'm gonna rotate this around so I can see the top. And I'm doing distance and angle chamfer because of my numbers on the sheet. Remember the 45 degrees by 0.3. So all I do, I just select the edge that I need. I'm adding my distance here, 0.03. And then my angle is already placed in there. And select OK. That's easy. Next step is to let's see, next step is to add the screw hole on the top. So I'm just going to create a hole on top. Before I do that, let me add a center point. So sketch on this, create and add a point right in the middle, and then finish sketch, and then I'll come back and add my hole. These are little things that you guys need to pay attention to because they do make your lives easier. If you do these little tiny steps like adding a point or you know, figuring out the distance and angle chamfer, they're like minor details that make a big difference. Okay, so we are going to do a drill point hole. It's going to be threaded, so we're going to choose tapped, and then let's see what else. It's going to be a 1/4 inch 20 UNC, so we're going to change this to 0.25, and that'll change this 1/4 inch 20 UNC. It is a 2B class hole, and then the depth is all we need to change here. So it's going down 0.4. Actually, it's already 0.4, so we're good there. And that's it. Everything was just a simple hole, threaded, drill point, distance down. There's no specification on the angle for the drill point, that's standard. And then just update all those and click OK. So now I have that into place. And what I need to do lastly is add this hole at the bottom of my shape. So I'm going to set up a tangent to plane. I'm going to select that plane and select OK. Then I'm going to sketch on this plane. Come down here. I need to add another point there. And then I'm going to dimension the distance the point is off of the bottom. And the distance that I have shown here is 0.395. There. Once that's in there, finish the sketch. We're going to add a hole. Excuse me. You can see add the hole. This one's just a simple hole. And click on that. And it is going, we have no drill point this time. And it is going all the way through. Let's see, so you just change it to all. And I need to update my diameter here. So it's not 0.9, it's 0.375. Enter, and there you go. This is just some saving things. So create a new project, name it the gear. All right, so I can close that, and I was going to do more videos for you guys, but I don't necessarily think that I need to. I believe that you guys can create the rest of these things on your own, because the most questions I've had were on the gear itself. So, but I will go through a little bit and annotate just so you guys know what's going on. This simple column here, you're just gonna make, I would do an overall rectangle. That's a terrible rectangle, but then you would just go back in, cut this out, so you wouldn't need that shape in there. And then you're adding a hole here, you're adding a hole here, you're gonna cut out this shape too, and then just fillet that back edge. So that's the overall drawing, and then you got hole notes. So these are just same as your drill block. You guys, it's nothing special there, just drill block holes. Even this is just a counter bore hole. The plus or minus are tolerances. This hole down here, counter bore as well. If you guys don't get those 100% accurate, it's not going to hurt my feelings, and it won't hurt your grade either. So just do your best on that. I know that you will have some questions, but at this point, I just want to get it done, and I'm pretty sure you guys probably feel the same way. So the next one down was the rack pad. What you're going to do, you're going to want to just create a you're just basically going to create a half shape here, and then just revolve it. If you set up the distance between this line and this line, and their distance this way and this way, what that's going to do is complete the angle for you. So you can just go back in and draw that angle lastly. So you have a line here, and you would have a line here. And then so the end point of this and the end point of this would connect and form an angle. And that's how you would get this rounded curve here. And then this bottom note right there, chamfer. Anytime you see a degree next to a distance, it's going to be a chamfer. All right, and then the last one that y'all have is the punch. This thing is very crudely set up. It's hard to read, and I get that. Basically, basically the most important things on this are going to be your holes back here because of where it attaches on the shape for when it gets set up to, let's see, when it gets set up on the back of this right here. All right, and then the other thing that you need to pay attention to on this is the size of your holes. So the size of those holes matter because if you're doing, you just want to make sure that they all fit. So the punch hole size is right here. The ×4 just means there's 4 of them, 1, 2, 3, 4, and they're 0.5 difference between each. These measurements give you your overall width, so they show you the direction here, and then they show you your direction there. Obviously this right here is showing you your distances this way and this way. I'm sorry, that way and that way. And then this number here showing you your inside right there. So you just got to kind of combine a few things here. These are showing you your holes on the back side. The distance there and there are your backside holes. And then the size, the attachment holes ×2. They don't show you a measurement for that, I believe. Yeah, they do, actually. It's right here. That note goes with these holes here. All right, so that should help out a little bit. And punch hole depth is right here. All right, so good luck. Please let me know if you have more questions, and I will be happy to help.